All right, so let's take a look. So we have benzoic acid, which is a white crystalline solid, is amongst common food preservatives and used in antifungal skin treatment. So we have the mass of the impure benzoic acid that's dissolved in enough water to form 25 mils of the solution. So we have a titration and we have the volume and concentration of the NaOH. Okay, we want the percent purity. So we have benzoic acid, COOH plus NaOH. This is going to form water, and we're going to have CH5COO with an Na on it. Okay, so we have volume 0.02376 and concentration 0.1052 moles per liter. Okay, so let's figure out the, let's see, what do we have? Let's get our mole value here since we have our NaOH. So this is going to be 2.5 times 10 to the negative 3 moles of NaOH. Okay, so because it's a 1-to-1 ratio, we know that the moles of this is going to be identical, right? So the 2.5 times 10 to the negative 3 moles, oh my gosh, not moles per liter, moles. Okay, so you can go about doing this whichever way you'd like. You can figure out the mass. So we can figure out, since we know the moles, we can get the molar mass and just figure out what the mass of this and compare mass to mass. So actually that's probably what I'm going to do. You can also do this by calculating the concentration and then getting the concentration of what should happen with the impure mass by doing the moles per liter there. Okay, but I find that if you have the mass given to you, you can find the mass pretty easily. So if we have the moles, right, so we want the mass from the titration results. Let me do this. Mass from, I'm just going to put from experiment, okay? So that's going to be our 2.5 times 10 to the negative 3 moles, and the molar mass for the benzoic acid is 122.12 grams per mole. So we end up getting 0.3053 grams from that, right? So now to determine the percent purity, we do the mass that was from the titration results over the original mass of the sample with impurities times 100. So this would give us 93.5%. Okay, so not the greatest. Usually when you're looking at purity, like, you know, let's say I'm buying a chemical and I want to do the reaction with it, normally anything that's above 95% is pretty good. So I'd say this is a little bit of a low quality one. But do you see how here the moles from this titration calculation is different than the moles that would have been if we just took the 0.3265 grams to determine it, right? So there was some extra things in there that was not reacting. Okay, so let's look at this other one. So we have a mass of an impure sample of calcium hydroxide, and it's dissolved in enough water to produce this volume. Okay, 25 mils of that sample was then titrated against a solution of HCl, and we have the volume of HCl. We want the purity. Okay, so we're going to have calcium hydroxide reacting with HCl, making H2O and calcium chloride. So that's going to be a 1-to-2 ratio. So it's a little bit different here. So concentration 0.0615 moles per liter. Volume is 0.01772. So if we find the moles here, right, it would be C times V. So our moles in this case is going to be 5.45. Oops, nope. My mistake. So the moles are going to be 1.0898 times 10 to the negative 3. So that is for HCl, right? So it is a 1-to-2 ratio. So we will have to get the moles of calcium hydroxide, we're going to have to essentially cut that in half, which would then give us the 5.45 times 10 to the negative 4 moles. Okay, so same thing here. Okay, so this is where it's a little bit different than that first example. So that first example, we used all of that mass in the titration process. But here it's a little bit different. They're telling us that this mole value was for what was inside of the 25 milliliters. So we know how many moles was in 25 mils. But in order to compare it to this mass, we need to figure out how many moles was in the entire 750 mils. So you have to then basically figure that out in another way. Okay, so if we have this many moles, let's get the concentration here. So the concentration of our calcium hydroxide is going to be our mole value over the 25 mils, which is then going to give us our 0.0218 moles per liter. Right, so the reason why I'm doing that is I want to figure out how many moles is in that 750 milliliters, right? So if I have the concentration by using that 25 mil number, I can get the mole value for the original, right? The the actual one that I can compare for the mass. So to do that, so we're just calculating this out, which would then give us 0.01635 moles. Okay, that's the one in the original one. So now we can find the mass. So the mass from the experiment is going to be 0.01635 moles times the molar mass, which is, so calcium hydroxide is 74.09 grams per mole, which gives us 1.211 grams. So that's our experimental mass. And we're going to compare it to our original mass. I'm going to do it over here. So our percent purity is going to be our experimental mass over the original number, which was 1.309 grams, times 100, which is 92.5%. So not the greatest sample. Okay, and the last one here, and then we're done here. So it's like nicotinic acid, also known as niacin or vitamin B3, is considered to be an essential human nutrient, and it comes in a whole bunch of different foods. So we have a sample of impure acid, and we're dissolving it in 30 mils. Okay, so there's no, you don't have this situation where you make the sample and then you have a new portion. So this is very similar to the first one. So you have just the mass and the volume. And we have the amount of base in order to reach equivalence point. So this one is actually pretty much identical to the first reaction, the first example that we did for the purity, right? So we have C5H4NCOOH plus NaOH forming water, and then we're going to have sodium with this. So we have here the volume, 0.0296 liters, concentration, 0.501 moles per liter. Right, so this is a 1-to-1 ratio. So we find the moles here. Once we have the moles, that's going to give us our mole value here. So once we have our moles, you would then determine the mass. Right, so we can do this actually pretty quickly. So here our number of moles is going to be 0.0105 moles, which is the same over here. So because we have our mole value of our acid, and there's nothing else we diluted or anything, that is the original moles, we can figure out the mass by doing our moles times the molar mass of our acid, so 123.11 grams per mole, which gives us 1.293 grams. So this is our experimental mass, right, from the titration. So for our percent purity, it's going to be 1.293 grams over the original mass, which was 1.361 grams, which will give us a percent purity of 94.98. Do we want 3 sig figs? We want 3 sig figs. So, 95.0%. Okay, so those are all the scenarios. I know it does seem a bit repetitive, but I feel like it's important to go through the different scenarios because they each have like a little bit of a different kind of take on it, right? So they give you information in a little bit of a different way. At the end of the day, they're very, very similar to one another, right? So you have something that's unknown, you have something you have information on, and then it's just a matter of figuring out how to work around it.